Now, inshallah, we will talk about the terminology of refraction. Terminology of refraction, it will give us some important notes about the terms that we have to use when we describe refraction and their definitions. Well, now, for anything, we agreed together that to talk about the diffraction, we have to determine the boundary between the two mediums. Okay, so we have here a medium 1, and here we have medium 2. So the first term that we will use is the boundary. This is the boundary. So the surface of water, for example, okay, it's the membrane or the surface that makes the limits between, or the limit between the two mediums. Well, the second term to talk about is the incidence ray. This is the ray that's falling on the boundary. So we call it incidence ray. And the point where it falls or meets the boundary is called the point of incidence. The point of incidence. Well, now before everything, we have to sketch a normal line. A normal line. This line should be normal to the surface, like this. This line is called the normal line. Why is it normal? Because it makes an or a right angle with the surface. Okay, so this is called the normal. So whenever I say normal, the normal, I mean the line that's normal to the boundary or normal to the surface. Well, now the incident ray will bend towards or far away from the normal. Now here, let's make it move far away from the normal, like this. Okay, sorry. Let's use the red. Here, this is the refracted ray. This is called the refracted ray. Okay, now we have to search for two angles. The first angle is called the angle of incidence, and the second angle is called the angle of refraction. We agreed together that the angle of incidence and the angle of refraction will be between the incident ray and the normal, not between the incident ray and the boundary. No, I'm not interested in boundary, in angles. Here, it's between the incident ray and the normal, okay? So, because it's the angle of incidence, we'll give it the symbol theta I, okay? So, theta I means angle of incidence. What about the angle of refraction? By the same way, it's the angle between the refracted and what? The medium and the boundary? No, and the normal. Okay, so it will be this angle. Okay, so this is the angle theta R, which is the angle of refraction. Okay, a few minutes ago, we said the refracted angle may bend away from the normal, and sometimes it will bend close to the normal. How? Let's see. Let's clear the drawings, first of all. If the light moves from denser medium to less dense medium, let's remember the following. Denser medium means higher refractive index, because the denser medium bends light more, so it has higher refractive index. You have to memorize this well. The denser medium also, it resists, we can say, as if it resists the propagation of wave, of light wave. So the denser medium has slower light waves or speeds, smaller speed. So denser medium means higher refractive index, means slower light speed or smaller light speed, okay? And shorter wave length also. Well, so if the light transfers from denser medium to less dense medium, let's see what will happen. This is the medium. Denser medium like what? Denser medium like, so this is the light, the incident ray, okay? And this is the normal ray, the normal, sorry, okay? This is the angle of incidence, theta I. Where will the ray bend? It will, it goes from denser medium. Denser medium means slower speed of light to faster. So we can say that the light will move faster. So it will move away from the normal. So the refracted light will be away from the normal. That means, let's put the arrows here. Okay, that means what? That means the angle of incidence, the angle of refraction will be more than the angle of incidence. So it bends away from normal. The opposite will happen here. From less dense. Less dense, we said less dense means faster, to denser, slower. So it will not escape away from the normal. No, it will bend towards the normal. Okay, so let's see what will happen here. This is the boundary, and this is the incident ray. This is the normal, and the light will bend towards the normal, like this. Okay, so the angle of incidence theta I will be more than the angle of refraction theta R. This is theta R here. Okay, so theta R is less than theta I. So we can say it bends towards normal. These two cases should be memorized and understood like your name. I know that you memorize or maybe you don't understand your name. Well, Snell's law. Snell's law is a law that determines the angle of refraction. We need a mathematical relationship to determine the angle of refraction. This relationship was experimentally introduced by Snell. Snell is a scientist. Okay, so this law is called Snell's law. It says Ni is sine theta I equal Nr sine theta R. What does it mean? It means simply we can say that this is the boundary. This is the first the incident ray. This is the refracted ray. This is the normal. Okay. The first medium where theta I is located called, it has a refractive index called the NR. Ni. I means incidence. Okay, you can say incidence or initial, but here it means instance. But let in the word initial reminds you it's the first medium. The second medium where refraction takes place has refractive index NR. For example, the first medium here is air, where N equals 1. Okay, and the second medium here is water, where N equal 1.3, for example. So we can determine that the Snell's law from this formula. Now Well, we can determine the angle of refraction from this formula. We know Ni, it will be given, and we know the angle of incidence, and we know the angle of the NR, the refractive index of the second medium, okay? Then we can get the angle of refraction, okay? So Ni is the refractive index of the first medium, theta I is the angle of incidence, NR is the refractive index of the second medium, okay? Sine and theta R is the angle of refraction. To make it clear, let's have this example. Let's clear drawings. Well, a light ray of wavelength of 589 nm, and M means nanometer, produced by sodium lamp. Here we will not use this, okay, but sometimes we will need this. Nanometer means times 10 to the power of -9 meters. Okay, so to change nanometer to meter, we will multiply times 10 to the power of -9, but we will not, again, we will not use lambda here in this formula because we don't have lambda in Snell's law. Let's continue. Traveling through air strikes a smooth slab of crown glass. Crown glass is a kind of glass at an angle of 30 degrees. So this is the first angle. So theta I is 30 degrees to the normal. Okay. What if this angle with what if this angle is to the boundary? Can we use it? No. We have to get the angle with the normal by subtracting from 90, okay, and use it, because we don't use angles with boundaries or surfaces. We use the angles with normals. Well, find the angle of refraction. Find the angle of refraction. So theta R is required. Well, someone may tell me, Mr. We don't have, there are missing givens. Yes, but one of them we know it well, which is what? Which is Ni. Ni of air. It's one. It's one. Okay. Well, what about the other? Let's look at this table. Here we find that the crown glass is 1.52. Okay. So in homework, the givens of refractive index will be uh, 2. Okay, then we will put the formula in I sine theta I equals in R sine theta R. Okay, by substitution we will find the answer as shown. Let's clear drawing. By substitution we will find the answer. To find theta R, as we agreed together, to find the angle from the sine, we use shift sine or sine -1. This is the formula. Okay, so theta R, this is made by the calculator. It doesn't need all these complications. Okay, so theta equal 19.2. You will substitute here. You will get the answer. Okay, and you can easily find the theta r. Finally, here, the two cases we talked about. The cat sees the fish by the waves, the light waves, those are coming from the body of the fish. Okay, the light here bends far from the normal. Why? Because it moves from slower light to faster light. So the light moves far away. So the theta r is more than theta I. So to the cat on the pier, that fish looks closer to the surface than it really is. Okay, and the fish sees the cat by the light that's coming from the body of the cat, which will transfer from air where the light is faster to the water where the light slower, so it will close towards the normal as we see. Okay, so here the fish will see the cat along the light ray that reaches its eyes, as we explained last term. Okay, so to the fish, the cat seems to be farther from the surface than it actually is. By the way, remember the following: we see the image along the ray that reaches our eyes, along the extension of the ray that reaches our eyes. That's what happened here, and also that what happened to the cat here. This is the ray that reached here eyes. Okay, so or its eyes. So the image of the fish will be along the extension of this ray. Thank you, and these questions, I'll show you these questions, and these questions will be, inshallah, sent to the channel as homework, and we will discuss them, inshallah, at the beginning of the next period. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.